my name is Bhavyashri, and in this lesson we will be learning physics of grade 6, lesson number 1, matter. In this lesson we will be seeing the theme of matter, what we will be learning, and the learning objectives. Shall we go into the lesson? Yes, you're ready. Let's see the theme of the lesson. Objects that take shape, have mass are called matter. A block of wood, milk and air are made of matter. Matter is made of tiny particles called atoms and molecules that cannot be seen by a naked human eye. As they are very small, matter exists in the form of solid, liquid and gas. A solid is a certain size and shape like a block of wood. A liquid like water has a size but does not have a defined like a shape. Now liquids don't have defined shape, right? Whatever the water that you're liquid that you're pouring into a container, it takes the shape of the container. It doesn't have its own shape. It doesn't have a defined shape. If you pour it into a vase or a glass, the shape of the object that you're pouring it into, it will take its shape. It takes the shape of the container it you put in. A gas like air is a form of matter that has no definite shape or size. So gas is just like air that is roaming here and there. It has no definite shape, no definite size, no nothing. It has no density, nothing. So today's theme is we'll be learning what is matter, the types of matters and how they are made of. So let's see what in this chapter we'll be learning matter and its composition. States of matter is what we are going to be learning in this chapter. We are going to see the learning objectives. Children will be able to define matter, describe what matter is made of, list of distinguishing properties of solid, liquid, gases, classifying them into different objects as solid, liquid and gas. So in this, after learning this chapter, you can be able to I can also classify the different objects between solid, liquid and gas. The three types of matter. Now let's go into the lesson, shall we? So first one is matter, its meaning and its composition. Let's learn. Let's go into the lesson. Yes, let's go. So the definition of matter. Matter is defined as anything which occupies space and has mass. So the definition of matter is defined as anything which occupies space and has mass. So this is also made of matter. Even us humans are also made of matter. We are solid matter. Now this thing occupies space and also has some mass. Mass is nothing but weight. Mass is weight. Let's see a few examples. Air, water, hydrogen, oxygen, sugar, sand, silver, steel, copper, wood, ice, alcohol, etc. are all of different kinds of matter because they occupy space and have mass, right? Like see, this water and hydrogen, oxygen are all air substance. So like each thing has a type of matter. Now some of them will be solid matter, some of them will be liquid, some of them will be gas. So there will be three types of matters that you can be segregated into. Now the water we drink is liquid form. The plates that we use for eating our breakfast are solid. And for gas is nothing but every day we breathe and we breathe oxygen, right? That's the gas. So whatever we do day-to-day activity, mostly we use all the three types of matters. So thus the word matter is used to cover all substances and materials, living or non-living, of which universal is a compound of. So matter is a word that covers all the substances and materials that are living or non-living, that is used in the entire universe. So let's see, did you know? Let's see a fun fact. Did you know the universe is a compound of matter and energy? Both matter and energy are interconvertible. Oh my gosh, did you know that? The universe is a compound of matter and energy. It's not only made of matter, it's also made of energy. Did you know that? Comment down below if you knew it. Now let's see the composition of matter. An ancient Indian philosopher thought that the matter is made of 5 elements: air, water, earth, sky and fire. Panchatattvas. So an ancient Indian philosopher thought the matter that we are using, the solid, liquid, gas, instead of all of this, he thought it was made of Panchatattvas. That means the 5 main elements of earth. The 5 elements like air, water, sky, fire, earth, right? So he thought they were made. His name is Maharshi Karna. So, an Indian philosopher was perhaps the first to suggest that all forms of matter are composed of extremely small particles known as Anu. So there was no atoms, no molecules. The Indian philosopher Maharishi Kannada actually named the small atoms that we are modernly calling now were known as Anu. And each Anu are maybe made of still smaller particles called Paramanu. That means Anu is molecules. Paramanu is atoms. So instead of molecules and atoms, he called them Anu, Paramanu. So they are the names of atoms and molecules. A Greek thinker, Democritus, called the smallest particle like the Paramanu, like the Indian philosopher said, no, Paramanu, as atom. So he was the first one to actually pronounce that Paramanu is actually atom. Thus, it was concluded that matter has a composed with a very large number of tiny particles called as atoms. A small drop of water contains about 100 million atoms in them. Even the small drop of water contains hundreds and millions of atoms in them. However, it was later found that the most of the atoms cannot be existed freely in nature. John Dalton, in the English chemist, experimentally found that matter is made of molecules. Do you remember John Dalton? Yeah, if you remember, comment down below. So he was the first one an English chemist to experiment all the things of matter and see that the Greek founder only thought atoms. He only found Paramanu. No one found Anu. So this English chemist John Dalton found molecules due to experiments on matter. A molecule is made of one or more than one atom of the same kind or the different kinds. So a molecule is made of one atom, let's say Paramanu. One Paramanu or more than one more Paramanu in different types. They can be same or they can be different. Like water is a compound. It's made of two molecules. What are they? Hydrogen and oxygen. And gold is made of 3 zinc. So like that, they can be same or different in molecular state. The molecule is the simplest and smallest particle of the substance that is capable of independent existence. What we saw, atoms cannot be independent in existing in freely in nature. But what about molecule? Molecule actually exists in the nature freely. Now let's see, both atoms and molecules are so small that we cannot be seen even with a simple microscope. Even though molecules are a little bit larger than atoms because the combination of matters, but still we can't see it even through a simple microscope. Okay, let's see a fun fact. Did you know a molecule is consisting of one atom is known as monadic molecule, example neon, argon, etc. So do you know the molecule that only consists of one molecule is known as monoatomic molecule? Now let's see the characteristics and particles of matter. The following particles are called as molecules, having the following 4 characteristics. So the molecules of the particles of matter is nothing but the molecules and atoms, right? So what are their characteristics? We are going to be learning now. First one, they are very small in size. We already know they can't be seen by a naked eye or a simple microscope. They have space between them. They are consist and random position. They won't be like in one position. They'll be in random position. They can be here, they can be there, everywhere. They're always attached to each other. They're always attracting each other in the same molecules. So let's see them in detail, okay? First one, particles of matter are very small in size. The explanation for this. All matter is made of large number of very small particles that are not visible to the naked eye. Okay, this is a small experiment. Let's see how the experiment, shall we? Take 100 ml of water in a beaker A and dissolve 2 to 3 crystals of potassium permanganate. So, it's an experiment actually that you can try or not. Take a beaker. Now let's name the beaker A, B, C, D. We'll need these many beakers. So in the beaker A, you will be putting 2 to 3 crystals of potassium in it. You will take a deep purple in the solution. Like after putting the 3 to 2 potassium, you'll get a really a dark purple. Now take 10 ml of the solution and mix it with 90 ml of water in a beaker B. So what they are telling, take the solution in beaker A and mix it. Take 10 ml of beaker A, and 90 ml of pure water and mix it together. Then what color are you getting? We'll observe that the color of the solution is not dark as the solution before. Now you see, I'll just explain it simply. Now in one beaker you're gonna be, okay, instead of taking all the potassium, take some food coloring. You'll put a few food coloring and it will be a dark color, whatever you like. Then if you take the same, take 10 ml and mix it with a little more than 10 ml, then it will become lighter because molecules have space like that. If they take the B is very light in color, right? Now I'll take the B beaker, take 10 ml. In C I'll put more water. Like that, if I put more water than the capacity of the color, then I'll get a really pale color at the end. Why do I am getting a pale color? Let's read about that. The solution becomes lighter and lighter. Okay, after this experiment shows that every single crystal of potassium is made of large number of tiny particles which can color a large volume of water. Now you observe, the first one is very dark. Why is it going paler and paler and paler as it's going? It's going pale because it is like mixing with the water, right? And molecules have space in them. Then very small, and they are like made of large number of tiny particles which can color the large volume of water. Now we can understand why the matter is so small. Now let's see that molecules and particles have space between them. Let's see about that. Now take two beakers, beaker A and beaker B. In both of them have the same amount of water. For example, 100 ml of water. Then take 20 grams of salt and dissolve it into one beaker. Then do you see any rising of the water? No. Why? Because the salt dissolves and takes place in the liquid molecules between the molecules. So it doesn't actually rise the water level, but if it is not dissolving, it can actually rise the water level. Instead of salt, you can also see if you add rocks or anything, they won't dissolve and they can't have space. So that's why the water level will go up. Now you understood why the particles have space between them. Now you understood how. Let's see that the particles of matter are consistent in random motion. Now like a particle of a random position. Now you can't see air, but you can feel air, no? Like air won't be coming in one direction, right? They'll be coming in the direction they like. So air, like it's been a zigzag motion. Most of the atoms are in zigzag path. So they'll be in a random position. You might have noticed that the sunlight coming through the minute opening in a darkened room, the fine dust particles appear to dance in random and zigzag position. Like whenever you see in a dark room, if a small beam of sunlight is entering, then you can see like small particles just jumping around. You'll be thinking maybe that's dust. Yes, it is dust. So they'll be mostly in a zigzag pattern. So like they'll be in a random position however they want. So now we saw how the atoms are in a random position. Now let's see how the matter attract each other. Each particle of matter always attracts to the another particle in the surroundings. The force of attraction between the following particles are known as intermolecular force of attraction. So the attraction between two molecules are known as intermolecular force of attraction. Thus, this force keeps a particle and matter together. So without this force, the matter won't even be together. Like it keeps all the matter together. It is a common experience that around us, some substances can change into powder, some others can change into small crystals and like broken easily. Now you can see. Okay, so like particles have attraction. Now they're saying they won't have their full form. They'll be changing. Some substances can be changed into powder. Like see, if you take, I'll tell you a small example. You can take rock salt. If you grind it, you get a powder form of it, right? Just like that. If you grind it, it won't be in the same form. You can change it through chemical or physical methods, the form of the matter. Force of attraction varies from one type to matter to another. Thus, the intermolecular force depends on the nature of each molecule and matter. It is a force of attraction between the particles of matter of a substance is less. The substance can be easily broken, but if it is more, then it is difficult to break. Now you see, some substances will be very soft. For example, you can take whatever you like. For example, we can take powder. Like they can be easily like if you take creams or powders that you use, cosmetics mostly, if you take a lipstick, it can be easily smashed, right? But if you take a rock, can you smash it? No, because in the lipstick there is less intermolecular space, but in the rock there is more attraction because it's made of solid matter. It is more compressed and it has a lot of power, but in the lipstick it is less power, so that's why it can smash it that easily. So now we saw these 5 things. We saw how they are very small in size, they have space between them, they are constantly in random motion, and they always attract to each other. So that's all for today. See you guys in the next class. Bye all.